Principles of Bioproduct Separation Module 3, Centrifugation, Segment 3. With me again, Yusuf from Institute Teknologi Bandung. Previously, we have discussed about settling of solid and different types of centrifuge. In this segment, we will discuss about scale-up of centrifugation. Designing large-scale centrifugations involve using laboratory data to predict performance of commercially available centrifuge. There are two approaches that can be used to obtain essential information for scaling up a centrifuge. First, equivalent time. It is a qualitative but the best starting point. Vendors often correlate this information with different types of large-scale units. Second, sigma analysis. It is a quantitative approach based on the analysis discussed in segment 2. The sigma factor is most useful when choosing between centrifuge on hand. Equivalent time. In this method, we can assess the difficulty of a given separation by calculating the product of the centrifugal force with time, as shown in equation 18, where R0 is the characteristic radius, often the maximum in the centrifuge. Typical GT values for a variety of biomass are presented in the table. Once the value of GT has been determined, a larger scale centrifuge that has a similar value of GT should be considered. One useful small-scale centrifuge for estimating GT is a commercially available gyrotester. It is a bench-scale centrifuge equipped with 3 interchangeable bowls. The first bowl is a tube holding unit. The second is a disc bowl for liquid-liquid separation. And the third is a disc bowl with a nozzle discharge for clarifying liquid-liquid suspension. The tube holding unit of the gyrotester is an excellent way to measure GT. The tube can be filled with 10 ml of suspension and centrifuged for 5 to 30 seconds. The degree of settling is observed for each time. Because the centrifugal force for a given speed is known, the value of GT can be easily determined. Sigma analysis. The sigma factor is most useful when choosing between centrifuge on hand. Equations to calculate sigma factor for tubular bowl and this centrifuge has been discussed in segment 2. The sigma factor for a tubular bowl centrifuge is as shown in equation 14, whereas the sigma factor for a disc centrifuge is as shown in equation 17, where Vg reflects the properties of the solid and sigma summarizes characteristics of the centrifuge. We must choose the required sigma value to meet the process requirements of Vg and Q. A gyrotester can be helpful in finding reliable values of Vg. For the next segment, we will discuss about centrifugal filtration. Until then, I am Yusuf from Institute Teknologi Bandung.